This is really a video that I'd highly recommend you pause and try to do as much as you can on your own. It's going to be very valuable to get that practice. And then maybe watch a little bit of the video if you get stuck and then pause it again and try to finish it. All right. So we're going to fill in this table for the graph and use it to make a graph of the derivative. The derivative tells us the slope of the original function, but the derivative itself is also a graph. And get this, the derivative also has a slope. The slope of the slope is something called concavity. All right. And then the slope of the slope has a new function, f double prime, which also has slope, f triple prime, which also has slope. Well, let's not go down that rabbit hole just yet. I actually don't remember if we go into that at all in this class, but it's a thing. All right. But let's focus on what we have to focus on. So the table says for all these x values, give me the function value, the y value, and estimate its slope. Remember, this is just slope, f prime. So when x is 0, the y value is 0. When x is 1, the y value is 1. Y value is 0 again. Y value is -1. Y value is 0. Y values, I don't know, 2/3. And then the y value is 5. And now we'll estimate all the slopes. What do you think the slope is right here? Well, let's extend the line a little bit and make it a little easier. We extend this line. What's the slope? Let's just look at 2 points and do rise over run. We're going up 1, right 1. The slope is 1 over 1. The slope is 1 here, about. All right. Next point. Well, this has a horizontal tangent line. It should have a slope of 0. Next point. What do you think the slope of this line is? Pick 2 points on it. Do rise over run. We're going down 1, right 1. The slope is -1, approximately. All right. And just keep on in this fashion, same way. Slope over here will be 0. Slope here is pretty steep. I don't know. Let's look at these 2 points. We're going up 1, right 1/2. Rise over run looks like this. If you simplify this, it's 2. And then again, this looks like another 1 again. Slope here. Let's get a better approximation. Over here, let's say it goes up 1/4. And right 1. Let's approximate and say the slope's about 1/4. You might have a different answer. That's fine. We don't have to approximate it the same way. So, fill in the table. We did that. Now, let's use this table to make a graph of the derivative. Let's make a graph. Oh dear, I don't like that. I don't know what just happened there. Let's make a graph of the slope. Sorry, this is all fuzzy, by the way. Well, when x is 0, the slope function is 1. So if we're plotting f prime as the point 0, 1, this is what the slope function looks like. Slope function gives us the slope of the blue at any point. At an input of 1, the slope function is 0. At an input of 2, the slope function is -1. And then at 3, it's 0 again. 3.5, it's all the way up to 2. At 4, it's back down to 1. Then at 5, it's like 1/4. So these are a bunch of points on the slope function. And then we can say, okay, around here, the slope is mostly staying the same until it quickly changes to 1. So the slope is mostly the same, and then it goes down to 0. Sorry, I meant the slope becomes 0 over here. And then notice, right, the slope is mostly the same all the way until 3. All right, so it's that negative slope mostly until 3, and then it jumps back again. And then between 3 and 4, the slope is that big number mostly. So the slope kind of stays up here for a while. Then at 4, the slope kind of slowly starts, right? The slope gets slowly less steep. The slope gets smaller. So the slope, I don't know, maybe curves like this. Your graph doesn't have to be exact. Should look something like this, but doesn't have to be perfectly like this. The important thing is that these red points are the same. And we can use this red graph to tell us the slope of the blue graph at any point. So that's where things get confusing. The value of the red is the slope of the blue. The slope of the blue is the function value of the red. We're going to be doing more of that in this next video. So even if you haven't looked at the homework yet, well, look at it, but let's do some problems together because graphs of derivatives are usually pretty wonky. So we'll be doing that in the next one. Good luck. Bye-bye.